Hello, I'm Mrs. Murdock, and I'm going to do a tutorial on how you can use Google Sheets to calculate average, standard deviation, and standard error of the mean. So if you have a very simple data set here that I just sort of made up, where you have growth of plants in millimeters after treatments of water versus fertilizer. So first of all, it would be good to recognize what the sample size is here. So a sample size is how many times an experiment was repeated per treatment. I've got two treatments here. One was a water treatment, which is a control, and one was a single fertilizer treatment. Within those treatments, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 plants whose growth was measured. So your sample size is n equals 9. So after watching Mr. Anderson's videos on calculating standard deviation and standard error, you may recognize that the symbol 9 means sample size. So sample size is incorporated into these calculations. And Mr. Anderson shows you the whole anatomy of those calculations, but in the AP Biology exams and in the work that I give you, you're not going to be required to calculate the standard deviation or standard error from scratch. You will be required to use the Google Sheets though. Whenever we have a lab and I want you to put error bars on your graph, you'll need to know how to do this. So here's a first example, a simple example of how to do it. And hopefully then you'll be able to use this for the rest of the year. So first of all, calculating anything using Google Sheets is very easy because Google Sheets already has formulas built into it that you can use and apply to whatever number set or data set you have. So first of all, to calculate anything in a cell, the cell that's highlighted here, you start with typing an equal sign. Now it understands that you're about to calculate something in that cell, and you can use things you've already, numbers from all over the screen, and put them in there, or use it. You start with a formula and then use a formula. So it's already used to me being on this page, and I've been calculating averages and things like that all day. So it's saying, oh, Mrs. Murdock, do you want to calculate an average, or do you want to calculate a sum? So just in case you don't know how, you're pulling something up and that doesn't give you those helpful things, the way you can access different formulas is by starting to type the word that represents the formula. So if I type AVER, you get all kinds of choices for calculating an average. Take the basic one, and you get a parentheses opener. Now you want to click and highlight the numbers that you want it to use to calculate the average. So I've done that. Now I press enter, and it does it for me. You see how easy that is. So now I have an average or a mean, right? Same thing, for this data set of plants whose only treatment was water. The other nice thing about Google Sheets is that you can, if you hover over the lower right side of a cell that you've just used a formula to calculate, and you click and drag it over, you will find that it will copy that formula into whatever cell you click and drag it on, and use the numbers above it to calculate a new average. So this is the correct average for the plants that were treated with fertilizer. So now that's done. Okay. So now, standard deviation, which is a very complicated formula, they have it built in here, so you don't have to do any of that from scratch, what the deviation is of each of these numbers from the mean, and then put it into that formula. All you have to do is type equals, and again, start typing the words that represent the formula. So STA, and if you do that, ST, and it comes up with the whole list of options for that. And what you want is ST diva, right? That's the one that you want. And if you do that, and then again, highlight the numbers that you want it to use to calculate it. Don't highlight your average. That's not part of your data. Click enter, and you have your standard deviation. And again, you can click across and copy it for this data set as well. All right. Calculating your standard error is the most important thing because that's actually the value that you need to put error bars on your graph. So standard error of the mean, that's what SEM means, by the way. SEM just means standard error of the mean, okay? Instead of a formula, you have to do a little bit more work here. So the actual formula for standard error of the mean is just the standard deviation you just calculated divided by the square root of the sample size, which is up here. So to do that, you go equal sign, you click on the standard deviation that you just already did, right? And there it is, B13, that's the correct cell, divided by square root is another function it does have. So you start to type that and it comes up with square root for you and you click on that. It's asking square root of what? You put in square root of 9 because you have 9 plants, that's your sample size, and you close the parentheses and you press enter and now you have your standard error calculated. You can pull this across and have it also done for your fertilizer plants as well. And it just turns out that it turned out to be 0.5 for both. All right, so then one last step. We're going to use 2 values of the standard error when we put error bars on our graphs. And in fact, you're going to find that that's what you're presented with. If you get a picture of a graph in a question, very often it's going to say 2 SEMs used. All you have to do for that literally is just multiply your standard error of the mean by 2. So equals 2 times this thing you already did. Click and you have it. There you go. And we pull it over here, and now you have the correct value. I think the reason for that is because of the significant figures that are going with both of those. That's why it's not just 1 and 1. But you now have the correct values to either put error bars onto a graph using the computer or doing it manually on paper. So now, if you want to make your graph using this environment, which is perfectly fine, I find it easier, and for the banana lab that we did, remember that I asked you to calculate averages, right, here and here, for your banana ripeness, right? So in this case, your treatments are water and fertilizer, and then you put the averages here. The plant growth for water was 21.9, and the plant growth for fertilizer was 25.9. The computer seems to respond better when you try to make a chart when you have it organized like this, as opposed to having your data kind of incorporated in with a lot of other raw data. Just makes it a little easier, maybe clearer, maybe easier to think about what you're doing this way. So the way I make a chart, and everybody, I think you guys, some of you are superstars at this and don't need this, but I'm just going to do this quickly. If you highlight this, including the top definitions of treatment versus the IV versus the DV, go over to Insert and go down to Chart. It will come up with a bar graph, which you can start to edit, give it a good title, make sure everything's labeled and with units and all of that sort of thing. But you have a good bar graph here. In terms of going further and putting the error bars on here, I'm just going to quickly show you how you might do that. And if you have your own way of doing it, that's fine, but this is how I figured out how to do it last year when I was having trouble with this. So if I go down here a little bit, okay, I know you can't see this because it's in the way of, I think my face is in the way of it. But what you want to do is you want to check the box that says switch rows / columns. You want to check that box. It's not letting me check the box. Maybe if I put myself up here. Ha! There we go. There. Okay, see what happens? So it actually brings the bars closer together and gives them each a separate color. And this allows you to separately add error bars to them. So now if you go to Customize and you go to Series, and instead of Apply to All Series, I want to do my water separately from my fertilizer, even though actually the error bars are very, very close in value. Okay, so my water, my error bar, I go to constant, and it was 0.9, I believe. There. So that one's done. See how it appeared right there? Okay, and then I'm going to go back up and go to the fertilizer bar. And go back down, and error bar that to constant, and that was, I believe, 1.1, and that made it, that makes it good. Okay, excellent. So now that is that is done, and you now have a correct bar graph with the correct error bars written onto it. So that hopefully that will be helpful for you. So what I want to do next, in my next film, I'm going to show you how to interpret what these error bars mean. We have 2 SEMs on these error bars for this data, and I'm going to explain exactly how to talk about that in a lab analysis in the next video, and I hope that was helpful.